In this video, we will be looking at qualitative analysis of some cations and the flame color that they produce when they are burned in fire directly. So, how do we do this? We actually take some salt onto a wire loop if we have it, and then we expose it direct to a Bunsen flame. Or we take some salt on a spatula and we put it in the fire. We expose it to the blue region of the flame because that is the region that is the hottest. We do not expose it to the orange region because orange region is also due to incomplete combustion of the gas that is there, which is lighting the burner. So let's look at these flame tests. Okay, so the ions that we are going to be testing for are Li positive ion, we take a salt of lithium, Na positive ion, a salt of sodium, K positive ion, a salt of potassium, Ca2 positive ion, a salt of calcium, Ba2 positive ion, a salt of barium, and Cu2 positive ion, a salt of copper. So we have three elements from group 1, lithium, sodium, and potassium, two elements from group 2, calcium and barium, and one transition element, copper. So now, when we take a solution, not a solution, we take a solid. In this case, we take a solid. And in order to perform it in our lab, we will be placing this onto a spatula, the salt, and we will be exposing it direct to the blue region of the Bunsen flame. So when lithium is exposed to the Bunsen flame, we can see a red colored flame being produced. This flame is very much visible and it appears just like it is appearing in the diagram which you can see. This is the color that is observed. It is very unique because you do not see this colored flame in normal cases. Now, with sodium, we end up with a bright yellow orange flame. It also has an appearance similar to the image shown here. We can clearly make out that the flame has turned orange or yellow, and this is due to the presence of sodium ions in our salt sample. Now, the difference between the image and the real flame happens with potassium. Here you can see a lilac color, which is quite dark. But when we perform this test practically, we do observe a lilac color, but it is very much light. It is not this dark. So we have a difference here in the image and the actual color that is observed, but the actual color can very easily be identified. You can see a light lilac flame being produced when K positive ions are introduced to it. So it is not difficult to identify, but it is a different color than the one shown in the diagrams. For calcium, we have an orange-red flame, more orange than red, but we can see a flame of a similar color to the one shown in the diagram being produced, and this color is very much different from the color produced by sodium because this has a red tinge to it. So that is why we call it a red-orange flame or an orange-red flame. This is for calcium. Okay, the next one, barium. This flame is the hardest one to observe because when we introduce barium ions into the Bunsen flame, a light green colored flame does appear, but it does not appear constantly or continuously, as was the case with all of the previous ions that we tested with the with burning them in the Bunsen flame. Here we will have gradual light green colors in the flame coming and going. So slightly difficult to observe, but the color is definitely light green. So the color for the barium ion flame test is a light green flame. And finally, we have copper ions being burnt and the flame produced is green. It says blue green. It is more green than blue, but you do get shades of blue in it. And this is also a constant flame and it is easily observable. So the different colors here are what needs to be remembered. And when these tests are carried out practically, some of the colors shown are the actual representations, but for lilac and for light green, potassium and barium, the lilac color is relatively lighter and the light green color is rarely observed. It is difficult to observe it. However, rest of the colors have a very accurate representation of what we see practically. So these are the flame tests for the 6 metal ions.